My name is Clay Smith. I'm a partner engineer at Lightstep, and this is a talk on using observability to generate chaos experiments in Gremlin using the Gremlin API and the Lightstep API. So in the next 10 minutes or so, we'll be doing a really brief demo that kind of dives into this in more detail. We'll also be sharing links at the end to actually see the code and give it a try yourself. But also, we'll also just be generally speaking about using observability data and what kinds of things you can use it in the context of chaos engineering as well. So one thing that both Gremlin and Lightstep have in common, I think, is a shared perspective on how modern software actually works. It's unfortunately very much closer to the photo on the right-hand side than the sleek flying car on the left-hand side. So Lightstep is an observability platform. We help SREs and platform engineers kind of track down problems and debug complex distributed systems. And the idea there is that using an observability solution like Lightstep, especially in conjunction with something like Gremlin, where you're actually creating chaos experiments, your team can build software more quickly and more reliably. And because we get the question all the time, monitoring versus observability, our perspective on the difference here is that with observability versus maybe searching through logs and kind of just repeating that process over and over again based on your best guess, an observability solution, at least in our view, should really help you validate a hypothesis quickly by surfacing the relevant data to you in the right places. So much less kind of going through a user interface or like querying or grepping logs and trying to get to that root cause really quickly and efficiently. And we think this is especially important when you're running chaos experiments, but it's also really important when you want to do more with that observability data in the first place. And that's exactly the use case we'll be getting into more today. So as I mentioned before, there's a pretty standard workflow for using observability in chaos engineering. You're likely already using this workflow if you're a Gremlin customer. And the idea is pretty straightforward. You're going to write some attacks based on your understanding of how things are running in production. Gremlin manages those. They start running, whether you are targeting containers or hosts or your application or infrastructure. Some intentional change goes out. That change, it gets measured using various types of telemetry, metrics, logs, traces, you name it. That gets sent to an observability solution. And from there, you're probably going to jump into a dashboard or some sort of user interface. Maybe you're also using command line tools to kind of understand, well, what actually happened there. So it's pretty well understood how that works. The use case we'll be going into today is kind of taking that one step further. And that's, well, what if we use the telemetry data from an observability solution not only to power a dashboard or user interface where you're kind of validating that hypothesis, but also writing code to actually programmatically generate new attacks from the insights in that data. So we're kind of excited to show you that. And one really important thing about observability telemetry, and one thing that makes it pretty interesting with traces in particular, is because traces show service-to-service relationships. So in this case, we have a kind of an abstract diagram here of this service calls this service calls this service. Those relationships alone have really important context to automatically kind of suggest or tell you where's a really good place to increase latency or increase errors. So just the relationships by themselves, unlike, say, unstructured logs or just metrics that power dashboards, there's enough data in here to do a lot of really interesting things with programmatically defining new types of chaos attacks. So we'll actually be showing what that looks like using traces right now. So if we jump into Lightstep, this is the Explorer view in the Lightstep product. It looks probably fairly similar to maybe other observability solutions if you haven't seen Lightstep before. There's a couple different things too. Of course, you see a histogram of latency. You can compare that in different time windows. But the other thing is, because it's built on distributed traces, you actually see this full service diagram here. So of all the services in your system, this is an example microservice application called Hipster Shop. It's a pretty standard front-end facing web application. It calls a number of downstream services. Those services also call other services. But you have this nice diagram here that shows all of these relationships. And from that, we can actually use the underlying data that powers the service diagram to kind of automatically generate latency between a call from the front-end service to the checkout service, or the front-end service to the recommendation service, or these other downstream services between the other downstream services. And after we run those chaos experiments in Gremlin, we can then see latency drastically increase in the tool. So just to show you what that looks like, we've written a little bit of JavaScript API glue code here. It doesn't do all that much. It just kind of queries the Lightstep API. It's going to grab a single trace here. And from that single trace, because trace data has service-to-service relationship information, we're able to see that the front-end service here calls 4 other downstream services: the product catalog service, the currency service, the cart service, and the recommendation service. So because we know that dependency exists, that the front end calls those 4 downstream services, we're going to automatically create a chaos attack between the front end service and all those other services. And so from there, we're going to call the Gremlin API and it'll create those attacks. I'll go ahead and run it again. It just takes a few seconds to do that. Great, created 4 attacks. Then I'm going to jump over to Gremlin. We'll see we have 4 new latency attacks that are pending. And then if we jump into each of those latency attacks, we'll see that the container label on each of those is different. And that's because the containers, we've targeted containers with a specific label. Our containers are labeled with the service name because the Lightstep knows the service name and Gremlin can know about container labels. We're going to say, well, for this one, we're going to increase the latency by 200 milliseconds for the recommendation service. We're also going to do it for the cart service, also for the currency service, and also for the product catalog service. So from here, we're automatically creating latency between the front end and all of those downstream services, specifically those 4. And so then these chaos attacks run. It takes, I think we've configured it for about 2 minutes. And then we jump back into Lightstep. Here's a chaos attack we ran about 10 minutes ago. We see a massive spike in the P99 and P95 latency. But then if we hover over here, we also see all of the traces that were captured during the latency attack. And so this is kind of the detail view of what's behind these metrics in this dashboard. Jump over to the trace view. We see all of the different calls between the front end and the downstream services. And then if we hover over each of these spans, which are the calls from the front end to the downstream services, we see it increased to just over 2 seconds. So we validated our attack, and we can see what kinds of things happen when that latency increases. In this case, by increasing latency between those 4 services, the experience is pretty drastically impacted. It goes up to nearly 40 seconds there. So hopefully this sort of scenario would not happen in your production system, but it's an interesting use case or an example of what happens when we kind of programmatically kind of define what a worst case would be based on this sort of service architecture. So we hope it's been a pretty interesting use case for you of what happens when you're actually using data from an observability API, specifically trace data, to connect that to the Gremlin API and automatically generate some new attacks. And also hopefully generate some new attacks that maybe you might not have thought of in the first place, or kind of identifying points in the system that are especially vulnerable to latency or errors or different sorts of attack types. So thank you for sitting through the demo. That's all we've got for today. We have some more information and some documentation and of course the code behind this use case at lightstep.com partners. Thanks very much.